Hello students, welcome to KK Mishra's tutorials. Today's topic is angular momentum, angular impulse and moment of inertia. What is angular momentum? It is the moment of linear momentum and it is always defined about a point. If the position vector of a particle with mass m from a point O is r and velocity v, then its linear momentum p equal to mv. And the angular momentum L of the particle about O is defined as cross product of R and P. Angular momentum L equal to R cross P. Since the cross product of two vectors is a vector itself, the angular momentum is also a vector. It will have a direction also. Consider particle with mass here with velocity v. So its linear momentum P equal to mv. Its direction will also be the direction of velocity. Now, by definition, the angular momentum L will be the cross product of R and P. So, it is a cross product and it will have a direction, and the direction will be along this line which is perpendicular to the plane containing R and V. Now, what is the magnitude of angular momentum L? It is equal to Rp sine theta. We replace P with mv, so it is mvr sine theta. We can write it is equal to mv into r sine theta, but r sine theta is the distance d. So the magnitude now is equal to mvd. So we can say that the angular momentum is the moment of linear momentum. The linear momentum is mv and the perpendicular distance between the point O and the direction of linear momentum is d. So it is mvd. Now we discuss moment of inertia. Suppose a rigid body rotating about an axis AB. All the particles are rotating in concentric circles and center of these circles lie on AB. Consider any particle rotating in a circle of radius Ri with its center at O on AB and mass Mi. If the magnitude of the instantaneous velocity of the particle be Vi, then the magnitude of angular momentum of this particle about AB is MIVI Ri. Let the angular velocity of the body equal to omega. So Vi equal to omega Ri. Now the angular momentum of the particle can also be written as MIVI Ri equal to Mi omega Ri square equal to Mi Ri square omega equal to I omega, where I equal to Mi Ri square, and it is called the moment of inertia of the particle about O, and sum of all moment of inertia of all the particles about AB is the moment of inertia of the body. The angular momentum is conserved. Just now we have seen that the magnitude of the angular momentum L equal to I omega. Hence dl by dt equal to di omega by dt equal to I into d omega by dt, because I is constant, moment of inertia is constant, and d omega by dt is the rate of change of angular velocity, and we write it as alpha, and it is termed as angular acceleration. So I alpha equal to gamma external, where gamma external is the total external torque on the body. Now if the total external torque on the body is 0, that is gamma external equal to 0, then dl by dt equal to 0. So L is constant. If dl by dt equal to 0, it means L is constant and not changing with time. In other words, if the total external torque on a system is 0, its angular momentum remains constant. This is called the principle of conservation of angular momentum. Now let us come to angular impulse. The angular impulse of a torque in a given time interval is defined as J equal to integration gamma dt. The time interval is between T1 and T2. Now dl by dt equal to gamma torque. So gamma dt equal to dl. Now J becomes integration gamma dt equal to integration dl equal to L2 minus L1, where L1 is the angular momentum at time t1 and L2 is the angular momentum at time t2. It means the change in the angular momentum is equal to the angular impulse of the torque. The difference and similarity between linear and rotational motion. While the linear motion is along a straight line, the rotational motion is always about an axis. In the linear motion, all the particles of the body move along straight lines. In fact, along parallel straight lines. And in rotational motion, all the particles move along circles with center on the axis but with different radius. The mass distribution of the particles with respect to this axis in the body is very important in the angular motion. This importance of the mass distribution reflects in the moment of inertia I equal to mi ri square. Even with the same mass, different shaped bodies will have different moment of inertia. Not only this, the same body will have different moment of inertia for different axes of rotation. Remember, moment of inertia has the same significance in the rotational motion as the mass has in the linear motion. Now, what are the analogous entities in linear and rotational motion? What mass is in linear motion? Moment of inertia is in rotational motion. What force is in linear motion? Torque is in rotational motion. What velocity is in linear motion? Angular velocity omega is in rotational motion. What acceleration is in linear motion? Angular acceleration alpha is in the rotational motion. And what linear momentum p equal to mv is in linear motion? The angular momentum L equal to I omega is in the rotational motion. Similarly, the impulse P equal to integration P dt in linear motion is analogous to angular impulse J equal to integration gamma dt in the rotational motion. This is all for today. Thank you. Visit again.